Hey everybody, this is Jan, and in this video tutorial we're gonna create our first project for the Nucleo STM32 board. If you haven't watched the first video, watch it first and it will tell you how to set everything up. Our board is using STM32 L152RE chips, so if we get more information on that and have it opened over here. Okay, let's open our STM32Cube and create new project. New project. Okay, this is a device selector over here. If you did build your own hardware or you have your own device, you would select your device over here. But since we are using pre-made board, we actually jump in here and select our MCU family, which is STM32L1, and this is actually our board over here. Okay, so we'll select our boards, click OK, and we get to this first overview where you have the pinout selection, your peripheral selection as well. You can see some of the pins have been pre-marked for us, and we're not going to use all of them, but some of them we'll have to use. So one thing we'll have to enable is our debugger connection, which we can debug which we can enable over here. So select serial wire. You can actually see the pins will get enabled over here. And for this tutorial, that's actually all we're going to need. Note over here, this is the pin where the green LED is. It's set as a GPIO output. There is also a push button which is set up as a GPIO input with interrupt, but we're not going to use this one in this tutorial. This page allows you to set up your internal clock of the device, and for our example we will choose to use the high-speed internal clock, and we'll connect it over here. So all of our peripherals will actually be running at 16 MHz. On the configuration tab, you can configure whatever peripherals you actually enabled over here, but we don't actually have to change anything over here. Feel free to explore though. In this section, power consumption calculator, you can actually explore and calculate the different power consumptions for different devices based on their run modes. If I open this a bit, you can actually see your device can be in run mode, sleep mode, or different, variants of stop mode or standby, and this will allow you to put your sequence in here and find out what your approximate power consumption is going to be. Okay, let's say this is our project done and we want to go and save it. Let's save it on the desktop as STM32L1, that's fine. Let's make sure it's here. Okay. The next thing we would want to do is to go under our settings, and STM32Cube allows you to generate code for those environments. Unfortunately, the Eclipse with the GNU ARM plugin is not listed here, but the one closest to it is the SW for STM32, so let's select that one and let's give it a name. Okay, code generator, the defaults are fine, but feel free to explore and advanced settings. Over here on some other devices, not this one, unfortunately, the SD allows you to choose the low-level library, which is marked as LL, instead of the HAL library, which is the hardware abstraction layer. The hardware abstraction layer is much more high level, but it's a really good starting point. Okay, let's go project and let's click OK. And that's our project configured, and we can now generate the code. Okay, let's close this, and you can see the code has been generated over here. Okay, let's open Eclipse. And let's create a new project. So we can go here and choose either C or C++ project. And we want to select the Hello World ARM Cortex-M C and C++ project. If you use any of the STM32F boards, then you can choose those templates as well, but they are set up slightly differently than ours. So, okay. Let's choose this one and give it a name. Click Next. And over here, the important part of this section over here is to select the correct processor core. If we have a look at our device, actually over here, you can see our device is Cortex-M3. So that's actually been selected over here already. But based on this selection, the compiler flags will be set. So if you do select Cortex-M0, you're going to get different compiler flags than if you select Cortex-M3 and so on. All those other settings over here, we don't care about because we're going to change them later. All those are fine, and that's fine as well. Okay, this is the setting for our toolchain, which we've set up before, so that's fine as well. Okay, here's our new project, which has been generated based on the template. And you can see there's a lot of files, a lot of code, but we actually are going to be using none of that. So let's select it all, right click and delete. Okay, let's get to our generated folder and drag all of the generated folders in our project. Make sure you select copy files and folders. And let's not forget the linker file over here. Let's put it under startup and copy as well. Okay, let's open everything so we know where everything is. Okay, close that. The first thing we would want to do, we have our startup file over here, which is written in assembly, and Eclipse is not comfortable with the lowercase x extension, so let's rename it. We have to make it a capital S. If you forget this, your code will build, but it will not run. Okay, the next thing is we can actually start setting up our project in here. If you select your project, right click, select properties, and we need to go C++ build and settings. That's pretty much where all of our setup is. The first thing we would want to do is to go under devices and find our device over here. If you don't have any manufacturers listed over here, make sure to go under the PAX plugin and install the relevant manufacturer and the devices you need. Okay, let's have a quick look. We are using STM32 L152RE. So STM32 L152RE. So that's our device. Let's click apply. And this configuration at the moment is actually our debug configuration, and we want to configure the release configuration as well. So let's select that one and click the same device and apply as well. Okay, the toolchain section is fine. We can leave that as is. And the tool settings, there's quite a few changes in here. Okay, so the first one, let's go on the preprocessor and let's leave debug, that's handy to have defined. And let's get rid of those two. And you can see we've got preprocessor for assembler, C compiler and C++, so we would want to change it for all of them. Okay, click apply. We don't want to rebuild yet. We'll do that when we finished doing our changes. Let's select release, and do the same thing over here. Okay, apply. Okay, go back to debug. The other thing we want to do is to choose our include folders. Those are the old ones from the template project, so let's get rid of those. Oops. Those as well. But I'm just doing the simple shift click to select them all and delete. Okay, let's select the includes over here and we can add our own include folders over here. So let's click there, add, browse our workspace, and we will actually, you can see over here, we would want to include this include over here, this one over here, the include for the HAL driver over here, and our own include folder over here as well. So let's find the first one. Okay, so that's our first include folder. Okay, let's find the second one, which is here. Okay, the third one is underneath the HAL driver. Okay, and the fourth one is right here. Okay, so that's all of our include folders. We can now shift click and select and do our Control or Command C to copy and paste it in the other locations as well. And click apply. Okay, let's change to our released configuration and do the same thing as well. So let's clear up the old include folders, put new, clear the old, put new one in, and clear the old and put new one in. Okay. So that's the includes and preprocessor set for both debug and release. And now let's do the linker. Let's go under linker general. Those are the old linker files we actually are not using, so let's get rid of those. And we also are not using the standard start files, so let's unclick that. On the libraries over here, we're not using that folder either, so we can get rid of that. Okay, let's switch to release and do the same thing. So clear that section, not using standard start files. We're not using that subfolder. Okay, and what do we want to actually, under general, we want to add our own linker file, which is this one. So let's add it over here, startup, linker file, okay. If I just copy it, switch to debug, then I can paste it here and apply. Okay, let's make sure they both set, they are. So we should be good now, and we can click apply and rebuild the index. You could see there was a quick progress over here. Okay, so that's our project should be set now. So we can actually, we are switched to console. So this is the build button over here. If you click the drop down, you can choose whether you're building for debug or release. So let's try to build for debug. You can see we've got some errors here, so we actually haven't built. And the reason for that is that the hardware abstraction layer, or the HAL library from ST, actually requires you to define your device, whichever device you're using. So I'll show you quickly over here. If you navigate to the CMSys device ST folder and select this header file, STM32L1, and you can actually see there is a bunch of defines over here, and the file is basically looking whichever device you are actually using. We haven't defined any of them, so that's why we're not building. So, okay, let's find ours, which is actually STM32L152RE. So that would be this one. Let's copy. Right-click on our project, properties, and we have to go to our preprocessor and can actually paste it there. And we have to do it for all the preprocessors over here. So let's paste it here as well. Here as well. Let's click apply, and let's do the same thing for release. So let's paste it here, here, and here. Apply. Okay. So let's try to rebuild again. Okay, and you can see we have built successfully. So that's our executable over here, all the different sizes, and yeah. Right, the next thing, we want to create our debug configuration. So this debug button over here, if you click the drop down, click the debug configuration, and let's make this slightly bigger, and you can actually see we've got the GDB Sager jailing debugging. So if you double click that one, it will actually create a debug configuration for your debug build. You can actually see this is the executable in the debug folder, which is right here, and that's been generated when we built. Sorry, when we built our project. So that's the project name, that's the location of our executable. There are some other settings for specific to jailing, and all the defaults are fine, so we don't have to worry about this. And that's fine as well, that's fine. And what I'd like to do over here is I'd like to save the configuration in a shared file, so it's always available to me. So if I click apply, you will actually see our debug configuration file was generated over here. Let's close that and let's build for release. Okay, so we have built, our release build is correct as well. And we would want to do the same thing. Let's go and drop down our debug configuration and double click the GDB Sager jailing debugging. And this is our release configuration. You will see this section wasn't filled in correctly, but can actually, if I copy from here, put it on there, but it's not our debug folder, it's actually our release folder. So you can see we've got debug folder over here, release folder over there. So that's where our executable is for the release build. And all the other sections as previously are fine. And we would like to store everything in a shared file as well. So if I click apply, see now we have the release configuration as well. Okay, let's close. Oops. Okay, if I open our main file, this is the simplest project the STM32Cube generated for us, and it actually doesn't do anything. It just initializes a few bits and pieces, and then it goes into infinite loop. So, which is fine, because we can at least test that we can actually program our board, which is what we are going to try, which is what we are going to do right now. Okay, so we do it in a way that we click the drop down here, go to debug configuration, and we can select either of those to whether we want to debug, whether we want to run as a debug or run as a release. So let me select debug and click debug over here. And this is a standard Eclipse questions. If you are running debug for the first time, it will ask you if you want to change the debug perspective. Is the Eclipse work in perspectives, and it suggests to you that you write your code in a different perspective than you debug your code in. So we can change that later. So let's click yes. And you see, actually, we started running our code and we stopped at the beginning of the main. You can see your stack over here. You can see your variables and breakpoints and registers over here. The peripherals actually are over here. So if you're interested in GPIOA, for example, you can click that. Sorry, that opened up over here. Let me put it here. And you can see all your internal registers for GPIOA. Okay, that's just a quick intro. Personally, I don't like this perspective, and I like the code red perspective, which I'm going to show you in a second. So let me stop this. And let me close this perspective over here. If you right click, you can choose close. It takes us back. And let's run preferences and type in perspectives. And we want to go under menu run and debug perspectives over here and select the one which is GDB Segger Jailing Debugging. What I actually prefer to do, I would like to have just one perspective for writing code and debugging as well. And for me, that's the code red, which I modify slightly as well. So I select both for run and debug, the code red perspective. Let's click apply. Okay. And right now, if I drop down, you can see that the previously run configuration is here, so I can select it. And I will get asked again if I want to switch to code red perspective now. And yes, I would want to choose this one, and I would want to remember it as well. Okay, you see we are running again, and this is slightly different. So let's just put a quick few modifications on here. If you click under Window and Show View, let's show registers, and I don't want them in there. Actually prefer to have them on this side. Okay, that's good. Peripherals I prefer to have over here as well. Expressions I can put down in here. And variables as well. This section I actually prefer to have down here, so I have more room for my code. Let's just make this smaller over here. And what else? Breakpoints, window, show view, let's debug this assembly. Memory. Let's put it up here as well. Is there anything else? I think that's pretty much all. So you can tweak it to your needs, and now when you're happy, what you need to do is right click on this perspective icon over here and do Save As. Then you can either put your own name, but then you have to redo your preferences. So I just like to override this default one. Okay. And next time I run it, I'm gonna have all those windows open as I like them over here. Okay. Let's do a few more changes in our preferences. Let me actually stop the program from running, and let's go preferences. And if I type in launch and go here, you see over here you have the option to always launch the previously launched application, which is quite handy. So I select this one and okay. What that does, you can just simply hit the debug button and it will run the last run configuration. So if I click this button over here, it will run our debug configuration. You can see we're actually running. The standard thing, you can see you have your step into, step overs, so we can step over things. I mean, we have nothing in there, so let me just stop that. Another thing I would like to do as well is, let me make a simple change over here. Let me add a line. You can see by this little star, you can see the file actually has been modified. But if I build, you see that the file hasn't been saved. So it actually does build your code, but it doesn't save the changes before building, and it's prefer to have it changed in the other way around as well. So let's, if we type in general workspace, okay, and over here you can actually see there is an option save automatically before build. So let's select that one, click apply and okay. And right now if I build, let me build for debug, you can actually see the file has been saved before it's been built. So that's quite handy. Okay. And I think we're pretty good right now. So let's try to put something interesting into our code actually. So we have something happening. So if you navigate to your main.h, this is where the STM32Cube likes to put the definition for pinouts. You can actually see we have our LD2 pin, which is our LED, and LD2 port. So let's use the HAL library. And so let's type in HAL GPIO, oops. And we can toggle a pin. And the LD2, you can actually see the first definition is for the port and the second one is for the pin. So we are LED ports and the LED pin over here. So that will basically toggle our GPIO pin. So if it was off, it will be on, and the other way around. And the another thing we want to do is let's put a little delay in there. And that's in milliseconds. So let's do, I don't know, 500. And let's see if it builds. And we build fine. And let's program. And run. And we have our LED flashing. Let me pause it quickly and let me take my webcam and put it on the board so you can actually see it running. Okay, you can actually see our board now with the LED flashing. So we actually managed to successfully program the board with our code generated from the STM32Cube code generator. Okay, thanks for watching. See you all later.